Hi dear students, welcome to Gita's classes. In the previous class, we have seen what is Laplace transform, what is the definition of Laplace transform. Now we are going to see the Laplace transform of some elementary functions. So in this class, we are going to find out the Laplace transform of k and Laplace transform of e power at and Laplace transform of e power minus at. In the previous class, I have defined the Laplace transform. What is the definition of Laplace transform? This you have to remember. L of f of t is defined as integral 0 to infinity e power minus st f of t dt. This is the definition, and it is defined for the function f of t where t is greater than 0. Okay. So this is the definition. Now let us find out the Laplace transform of the functions. First is k. So by definition, whatever you have here, this function, this should be multiplied by e power st and should be integrated from 0 to infinity. So by definition, integral 0 to infinity e power minus st into whatever you have here, that should be written here. So k. L of f of t means f of t. So here you have k, so k into dt. K is a constant. Here we are integrating with respect to t, so it is independent of t, so it is a constant. I can take k outside. So integral 0 to infinity e power minus st into dt. What is the integral of e power minus st? K into e power minus st divided by, with respect to the variable t you are integrating. So whatever is there, the coefficient, that should be written in the denominator, that is minus s from 0 to infinity. Now minus s also I can take it outside, so minus k by s into e power minus infinity. Wherever you have t, you apply the upper limit first, minus apply the lower limit. So e power minus infinity minus e power 0, right? So this is equal to minus k by s into e power minus infinity is 0 and e power 0 is 1. Therefore it is k by s. Therefore L of k is equal to k by s. And if you substitute, you write a note, if you substitute k is equal to 0, then L of 0 will become 0. If you substitute k is equal to 1, then L of 1 is equal to 1 by s. Okay, so these elementary functions you have to remember. The Laplace transform of elementary functions are important for doing the problems. So second one, this is first one, L of k we have found out. Next, let us find L of e power at. By definition, it is integral 0 to infinity e power minus st into e power at into dt. So this is equal to integral 0 to infinity e power, you can write e power a or a power m into a power n is equal to a power m plus n, you can write. So e power minus of s minus a into t into dt, that is minus s plus a. So I am taking minus outside, so minus of s minus a. Okay, so integral 0 to infinity e power minus of s minus a into t dt. So if you integrate e power minus of s minus a into t divided by minus of s minus a from 0 to infinity. I can take this minus 1 by s minus a outside, and in the limit if you substitute e power minus infinity and e power 0, because in the place of t, with respect to which variable you are integrating, you have to substitute the limit. So t is equal to infinity and t is equal to 0. So this becomes minus 1 by s minus a into e power minus infinity is 0, e power 0 is 1. Therefore it is minus minus, it will become plus. So 1 by s minus a. Therefore L of e power at is equal to 1 by s minus a. These are all important functions. Laplace transform of the various functions, standard functions you have to remember. Similarly, L of e power minus at is equal to, you can just replace a by a minus a also, you will be getting 1 by s plus a, you can directly write, or integral, by definition it is integral 0 to infinity e power minus st e power minus at dt. That is integral 0 to infinity e power minus of s plus a into t into dt, minus s minus a. So integral, if you integrate e power minus of s plus a divided by minus into t minus of s plus a from 0 to infinity. So minus of 1 by s plus a, I am taking it outside. So if you substitute the limit, e power minus infinity minus e power 0, that is minus 1 by s plus a into e power minus infinity is 0 minus 1, therefore it is 1 by s plus a. Therefore L of e power minus at is equal to 1 by s plus a. Okay, this is again important. Now next is, so what we have studied now, L of k is equal to k by s, or L of 1 is equal to 1 by s if you substitute k is equal to 1. L of e power at is equal to 1 by s minus a, and L of e power minus at is equal to 1 by s plus a. These are all important functions, Laplace transform of some elementary functions. So some more functions we'll see in the next class. If you like that, if you feel that this is useful for you, please give a thumbs up and share with your friends so that it will be useful for others. Thank you so much for listening.